Hello engineers. Welcome to part B of cold stretching of austenitic stainless steels. So what are the key requirements or essential requirements we need to follow, or what are the general requirements we must need to have before starting the cold stretching points? Okay, cold stretching process. So let's begin the session. So general requirements. So the first point you need to consider is uniform thickness, guys. So whatever the thickness you consider for your pressure vessel, that shall be less than 1.2 inch and uniform throughout the cross section. For uniform thicknesses only we are doing the cold stretching process. For non-uniform thicknesses we are not prefer cold stretching process. Why? For non-uniform thicknesses, whatever the, for example, if your thickness is up to here is this much and after this is this much. Let's for example. So this is 10 mm, this is 12 mm. So at this area, stress concentration is generally high at the discontinuities area, stress concentration is generally high. If you do cold stretching process, we know that cold stretching process means enhancing the properties and enlarging the atoms in the material, right? So here, whatever the atoms in the material, so it try to create dislocation. So it will try to failure, it try to come outside. Okay, so that's why failure happens more easily while doing the cold stretching. So that's why we are not preferring so non-uniform thickness while doing cold stretching for your pressure vessel. You need to confirm whether you are using uniform thickness or not. So generally also we need to use uniform thickness only. Then only stress concentration is less. Otherwise your stress concentration area is high, which results failure in your pressure vessel in practical applications. Okay. So first point is uniform thickness and your thickness must be less than 1.2 inch only. So for higher thicknesses we cannot perform cold stretching because that pressure is not sufficient to enlarge your circumference of your pressure vessel. So it is difficult to enlarge the atoms in the material. So that's why we prefer generally it is less than 1.2 inch. Okay. And the next point is so whatever the openings we provided in this shell, whatever the openings we provided in this shell, that opening shall be less than 6 nps inch size. And whatever the openings we provided at the center of the at the center of the pressure vessel, that shall be less than or equal to 8 nps. So whatever the nozzles or openings you provided in this shell is less than 6 nps size, and whatever the nozzles you provided at the center of the head, you need to must provide 8 nps instead, less than or equal to. So both 6 or less than 6 or 8 or less than 8. So this is the another point. And so while providing your nozzles or openings, so we generally keep reinforcement pads, right? So but in this reinforcement pads are not allowed because here discontinuities area is there. This is not allowed because this will create high stress in the area while doing the cold stretching pressure. So this is so we need to avoid reinforcing pads. Okay. And cold stretching minimum temperature is minus 320 degrees Fahrenheit and cold stretching maximum temperature is 120 degrees Fahrenheit. So you need to mention sure that your higher temperature is 120 degrees Fahrenheit and your lower temperature is minus 320 degrees Fahrenheit. Okay. So for this type of pressure vessels only you need to do cold stretching. Generally for UHA vessels, generally for UHA vessels, your high temperature is 150. But here you need to under for hydrogen vessels, so your minus temperature is minus 423 degrees. So for this temperature, cold stretching process is not considered. You only consider cold stretching process for 120 degrees Fahrenheit up and minus 320. In between these temperatures only you need to do cold stretching operation. For higher temperatures and for lower temperatures below minus 320 degrees Fahrenheit, you cannot do cold stretching operations. So this is the one more point I need to tell to you guys. So let's discuss one by one. So I already told you your vessel wall thickness is less than or equal to 1.2 inch and your MDMT not colder than minus 320 degrees Fahrenheit. And whatever your maximum design temperature is less than or equal to minus 320 degrees Fahrenheit. And you need to maintain uniform diameter. And for dished heads you need to must use only dished heads like torus spherical ellipsoidal heads. You need to use it for your vessels if you are doing cold stretching operation for your pressure vessel. So generally this cold stretching process is used for cryogenic vessels because at negative temperatures it will have a good effect. Okay, so that's why we are doing the cold stretching operation. And next, applicable for vessels which are designed under internal pressure. So only we are doing this cold stretching operation for internal pressure. So I already told you, right? So we need to maintain 1 P to 1.6 P pressure, right? We need to maintain this pressure, right? So this pressure is internal pressure. So we are doing this cold stretching pressure for internal pressure only. Okay. And next one is nozzles which are provided in the shells and heads shall be less than or equal to 6 nps in size. So whatever the locations you are providing the nozzles, so this must be in 6 less than or equal to 6 nps in size. And whatever the nozzles you provided at the center of the head, that must be less than or equal to 8 nps in size at the center of the head only. So whatever the filler material you used for welding, so the ultimate tensile strength for that filler material is greater than or equal to ultimate tensile strength of your base material. So this is the one more important point. And we need to avoid reinforcement pads. So all these general consideration need to consider before doing the cold stretching operation. So let's see what are the materials we need to generally use in cold stretching operations. So let's see materials which are used for pressure vessels for cold stretching operation. So if you refer ASME BPVC Section 8 Division 1 code, mandatory appendix 44. So in that mandatory appendix 44, you will find table 1. So that is table 1, allowable materials and design stresses. So I already told you, so in cold stretching process, we are enlarging the vessel, we are enhancing the material properties, right? So definitely the allowable design stress in tension also increase it to this much. So generally for SS 304 material at 100 degrees Fahrenheit, so at 100 degrees Fahrenheit, 20 KSI is there generally. But after cold stretching, it will increase it to 39.3 KSI. So from 20 to 39.3 KSI. So this is the use of cold stretching process. So which is used for high pressure applications. So why we use only these materials for cold stretching process? So why we are considering 304, 316 only? So unlike other types of stainless steel materials, austenitic stainless steel maintain their toughness at cryogenic temperatures. So this is due to their face center cubic crystal structure, which prevents brittleness. These steels can undergo significant deformation without breaking, so which is crucial for handling the stresses associated with cryogenic application. And the austenitic stainless steels, such as 304, 316, offer excellent resistance to corrosion, which is essential for the longevity and safety of cryogenic vessels. The mechanical properties of austenitic stainless steels remains stable across a wide range of temperatures, which ensures reliable performance in cryogenic environments. The steels can be easily welded without compromising their mechanical properties and making them ideal for constructing in pressure vessels. So that's why these 304, 316 materials are generally considered. If we compare 304 and 316, 316 have more resistance to wear and corrosion. So generally we prefer 304 for smaller applications and 316 for most high pressure and corrosion resistance applications. So these are the materials we generally use for cold stretching process. And next one, so important points we need to consider while designing the pressure vessel for cold stretching. So the first one is if required, if required to support loads, no more than two rings shall be placed inside or outside of the vessel. The rings must be made up of stainless steel. So what does it mean? So this is our shell. This is our shell. So this is our welding area. Okay. So from shell to shell we will weld, right? So this is the weld area and this is the shell. So sometimes we will provide stiffener rings, right? Sometimes we provide stiffener rings for extra strength. So if you want extra strength, you maximum allowable stiffener rings is only two. Not more than two rings shall be not prohibited in one shell. So you can use in another shell if you want. If you want, you can use in another shell also. Okay. But in one shell, one segment, you need to provide only two or less than two. So not more than two is not allowed. Okay. That too, the material used for the stiffener ring is must be stainless steel only. So this point also mentioned in the code. And the distance between centroid of the ring and any structural discontinuity must be at least. So what does it mean? So whatever the distance between centroid of the stiffener ring and structural discontinuity. Structural discontinuities means so at welding area it is discontinuities area. Or you have any nozzle here. So the distance from here to here, the distance from here to here must be A. So the A is nothing but this one 1.1 times of d naught into t whole power 0.5, where d naught is the shell outside diameter before cold stretching and d is normal shell thickness before cold stretching. I hope you are understanding my point. You must need to maintain this distance from any discontinuities from centroid to the center of the discontinuity. Okay, so I hope I cleared this point. And next one, ring must be attached to the shell using either continuous double fillet welds or full penetration welds. So if you want to connect your stiffener ring with a shell, so through welding only, right? So generally we prefer welding only. There is no option, right? So we need to use double fillet weld. Double fillet means, so like this it will be there. Both sides. Both sides we need to weld like this, okay? Both sides we need to weld. So this is generally double fillet weld and full penetration weld need to be done. Full penetration means throughout the length we need to weld between shell and the stiffener ring. And next one is the cold stretching pressure shall not be less than 1.5 times the design pressure. Minimum we need to maintain 1.5 times of pressure and maximum 1.6 times of design pressure. And next one is the inside knuckle radius of formed tori spherical heads shall not be less than 10% of inner crown radius of the head. And radiography examination or ultrasonic examination shall be performed prior to cold stretching operations. So before starting the cold stretching operation, I already told you you need to perform radiography examination or ultrasonic examination to detect if there are any defects or not. Okay, if there are any defects, we need to clear, we need to give one solution to clear out the defects. After the defect free only, we will perform cold stretching operation. So renewed cold stretching shall be performed if cold stretched parts of the vessels have been welded after cold stretching. If you done any welding after cold stretching process, we need to do re-cold stretching operation for that parts or for and their vessel. So except for tack wheels less than 0.5 inch in length. So whatever the tack wheels which have length 0.25 inch in length, so no need re-cold stretching, okay, for this wells only. Otherwise, we need to do re-cold stretching. So I need to clear this point, guys. The knuckle radius of formed toruspherical shall not be less than 10% of the inner crown radius. So this is the typical toruspherical head. So this is the crown radius. This is the knuckle radius. This knuckle radius shall be greater than 10% of your crown radius. Okay, crown radius. So this is what the point told to us. Okay, so this is all about cold stretching process and the important points we need to consider while cold stretching and before cold stretching. So if you like the content, please share to your friends. Please subscribe my channel and hit the like button. Thank you. Jai Hind.